Hello, ladies and gentlemen. We are going to continue talking about surface area and volume for prisms and cylinders, except now this video is going to talk about cylinders specifically. We've already talked about prisms in a previous video, and if you missed that, you can find the previous video on Google Classroom or on YouTube. And this video is all going to be talking about cylinders. So again, this is the foldable that we're in. We've already talked about this and this in the last foldable, so now we're going to be only talking in this foldable about cylinders. Granted, we have talked a little bit about cylinders in the vocabulary section, but now we're actually going to solve problems involving cylinders in this tab of the foldable. So first off, we're going to talk about surface area cylinders, and just like we talked in the prisms, it's the total area of all the surfaces of the solid, except a cylinder is a little trickier because of this rounded edge right here. So we know that the area of the circle, or the base, or the top and bottom, is going to be the area of a circle, which is pi r squared. And of course we're going to have to do that for the bottom as well, pi r squared. But what about this middle piece? So if we were to draw it what's called a net, or if we were to flatten this piece or image or object into like paper that's going to be wrapped like a Christmas present. So like if you're wrapping like a Pringles can, and we were to unwrap just the area that you used, like the minimum amount of area that you would use to wrap a Pringles can, this is what it would look like flattened out. It'd be pi r squared for this circle, pi r squared for this circle, and then this is a rectangle, which is going to be length times width. But if we think about it in terms of a can, this is the height, which would be this distance here, and then this distance is what's wrapping around the base of one of those circles, or like the cap of the Pringles can. So this distance all the way around is actually the circumference, or the perimeter of the circle. So the circumference times the height. If you don't remember what the circumference is 2 pi r times the height. So we're going to be adding this plus this plus this for the surface area of a cylinder. Okay, so find the surface area of this cylinder. So remember, we're going to be doing surface area. Well, the base is pi r squared, but we're going to need 2 of those, times 2 once we get our answer. Plus, remember, if we have that soup can label, or that extended portion, if it was fanned out, it's going to be the circumference times the height, which is 2 pi r times the height. So we know that the radius is 3 and the height is 4, so it's simply just plugging in numbers. So I'll write it down here. So surface area, well, the area of one of the bases is pi r squared, so 3 squared is 9 pi, times 2, that's going to get me 18 pi for both the top and the bottom, plus this circumference, which is 2 pi r times h. Well, the circumference is 2 times 3, which is 6 pi, and the height was 4, so times 4, so 6 pi times 4. Well, 6 times 4 is 24 pi. So now we just add 18 plus 24 pi for a total of 42 pi surface area. But nobody talks about how they need 42 pi feet squared of wrapping paper for their Christmas presents. So if you want, you can choose whether you want to, for the sake of our homeworks and our tests and all that stuff, if you want to keep it in pi, or if you want to use the decimal. Sometimes I only keep the final answer in pi to prepare you for standardized testing like ACT or the ACT Aspire, okay? But if we were to actually plug into our calculator 42 times the pi button, our decimal would be 131.9467 feet squared. So that's our surface area. Remember, surface area is in squared units. Okay, let's look at example number 2. So now we need to find the radius given the surface area. So if this surface area is equal to 2 times pi r squared, because pi r squared times the top and the bottom, so that's why we get times 2, plus their circumference, which is 2 pi r times the height. So we know that the height is 9, and we know that the surface area is 104 pi, so we have to find r. So 104 pi is equal to 2 pi r squared, that's all we know about that, plus 2 pi r times the height, which is 9. Well, I can multiply the 2 and the 9, so I can simplify that. So that's 104 pi equals 2 pi r squared plus 2 times 9 is 18 pi r. Okay, so if you notice, we have a r squared and an r and a number. That means that we're going to have to factor, but we want to get rid of as much as we can so that we don't have a hard problem to factor. So I notice that each one of these terms has a pi and they're all even, so let's divide by 2 pi. To just make this equation a little simpler, let's take out a GCF, so we can take out pi out of everything and we can divide out a 2. So 104 divided by 2 is 52. 2 divided by 2 cancels, so that just leaves me with an r squared, plus 18 divided by 2 is 9r. Remember, when you factor, we need everything on one side of the equation, so let's minus that 52 to the other side. So we have 0 equals r squared plus 9r minus 52. So now we have since our r squared doesn't have a number in front of it, we can just set up our parentheses right away. R times r. So if we have an equation like this, we're asking what two numbers multiply to a negative 52 and add to 9r. So some factors of 52. Well, that's 2 and 26, but that's not going to add or subtract to 9. Let's see if 52 is divisible by 4. Well, 52 divided by 4 is 13, and 13 minus 4 is 9. So we can use 13 and 4, but we want the 13 to be positive and the 4 to be negative so that those two numbers can add back to a 9, and they definitely multiply to a negative 52. So remember, our solutions then are if we set 0 equal to r plus 13 and solve, so minus 13 minus 13, we get r is equal to a negative 13. And then if we set 0 equal to r minus 4 and we add 4 to both sides, add 4, then we get 4 is equal to r. Okay, so now we have two answers, but we're in the context of volume, or excuse me, surface area of a cylinder. We can't have negative lengths for a radius, so that means that my radius is 4 inches. Woo! There was number 2 for surface area. Moving on to volume. Okay, volume of a cylinder. We already talked about how volume brings in that third dimension of a height. So we're going to use the same formula that we did for a prism, except now big B is going to be the area of the circle, or pi r squared, and h is still the height of the cylinder. So our volume is still going to be big B base times the height, where big B is the area of the base, and in the case of the cylinder, it's a circle. Alright, so we have the same picture for this number 1 as the last number 1, except now we're going to find the volume. So the volume is big B times h, where big B is the area of the circle, which we know is 3 squared pi, which is 9, times 4. So 9 times 4 is 36 pi. You can leave your answer in terms of pi, or if you want the decimal, that's 113.0973. Oh, excuse me, that was funky. Don't know what happened. 0973 feet cubed. Remember, volume is in cubic measurements because you have length times width on the bottom, all times the height. So it brings in that third dimension, 3D shapes. So it's feet cubed. Okay, number 2. Find the height given the volume. So now we have volume is equal to big B times h, but now we know that V is 9 pi, and we know that, we need to find the area of the base, and we need to find h. Okay, so we can find the area of the base. Okay, so let's find big B. So big B is going to be 3/4 our radius squared times pi. Ooh, when we square a fraction. When you square a fraction, you're squaring the number in the top and the number in the bottom. That's back to algebra 1. So 3 squared is 9, 4 squared is 16. So that is big B. So we have 9 pi is equal to 9 pi over 16 all times h. If we're multiplying by h, this number times h, in order to undo whatever's happening on this right-hand side to get h alone, we have to undo multiplication, which means we have to divide by 9 pi divided by 16. But when you divide two fractions, that gets really ugly. So when we divide by a fraction, we can also multiply by the reciprocal. So we can multiply by 16 over 9 pi. Remember, 9 pi is all over 1 technically. So if we take 16 times 9 pi all over 9 pi times 1, these are just going to cancel. So we get 16 is equal to h, or 16 over 1, where h is 16 feet. If you need a little more help on that guy, you can definitely ask me when we get to class. Also, if you plug everything into your calculator and you don't actually do the algorithmic stuff, you will find that h is 16 feet. Okay, that is all that I have for you guys today. So with that, I guess just make sure this whole foldable is filled out. So if we go back a couple, just make sure that this whole entire foldable is filled out, because now we've talked about prisms and cylinders for both surface area and volume. And so make sure both of these tabs, or all three of these tabs, are filled out. And if you did not get the first portion of this foldable, go back to the separate video. With that, I just want to thank you for taking good notes, and I'll see you soon.